Hi guys, I know some of these videos tend to be long, so I'm hoping this one's a shorter one. Um, the assignment looks tough, but I think you guys will fly through it. So we're still sort of in probability, which means we're going to be thinking about things in terms of relative frequency. Um, yeah, let's jump into this. Where are we? Uh, all right, so this is 5.2, addition rule, complements. It's essentially saying with addition rule that when we have an or probability, something or something, if they're independent or mutually exclusive, then we just add the two probabilities. So I know that's pretty wordy explanation, but let's see what that means. Okay. Um, First question, we have S. S is our sample space. This means sort of the total number of things that can possibly happen. Um, and they're asking list the outcomes in E and F. So what would the outcomes in E and F be? And that one's not too bad, so I'll leave that for you. Because remember, I don't want to do all of these. I want you guys to think about this. And that's one you can definitely get. Okay. Question two, list the outcomes in F and G. So what's the total outcomes here? We have 8, 9, 10, 11, 12, 13. So for this one, you just write them out. These are the outcomes for F, and G is 12, 13, 14. But we already have 12 and 13 from E, so we just need 14 and 15. And this would be the answer. Okay, that's that. Then the other part will just ask about probability of events. Okay, I think you guys can do that. Um, let's go on so this is the other topic that it's not really that big in this section. I don't know why they title it that, but complements are like, think of it as opposites. Okay, so a complement is the opposite. So first question here is saying E complement. Well, what's E? E is 8, 9, 10. Why is my marker not right? There we go. So E complement would be every event in S that's not 8, 9, or 10. So it'd be 7, 11, 12, and all the rest. Okay. And then the probability part, you guys can probably do. Just gonna think about the total number of things in each thing. Question four. Okay. Um, so for this is a formula, and I'm gonna pull it up right here. Well, I'll just write it. Probability of E or F. This is in general. So the probability of something or something is equal to the probability of the thing plus the probability of the other thing minus the probability of the intersection or E and F. Okay. So that's just a formula. If you open view an example, that's exactly the formula it'll have. And so we're asked to calculate this, so we have to do probability of E, which is 0.3, plus probability of F, which is 0.55, minus their intersection, which is 0.05, and then that gives you the answer. Okay. Pretty quick one. And this, like I said, I hope this is a really fast video because I know you guys like them to be a little bit shorter. This one, since they're mutually exclusive, we just add the probabilities together. Okay. Uh, Probability, this is a good question. So if this is the probability of E happening, then probability of E complement is 1 minus the probability of E. So P of E complement, because we think of 1 as 100%. So it's just 1 minus the probability of E. Okay. So that's how you do that. That's a really important um, concept to know. Uh, Golf ball contains 8 balls. 8 balls of type 1. Why is my thing not working? 8 balls of type 1, 6 of type 2, 4 of type 3. Well, how many balls is that? That's 8 plus 6 plus 4. That's 18. So the probability that a golf ball is type 1 or type 2 is the number of type 1, it's the number of type 2, divided by the total, so 14 by 18. Okay, and simplify. Moving on. See, we're almost halfway through, guys. This is a pretty short section in terms of time it takes. Is that the same one? Did I click on the same one again? Nope. So this is just like the previous one. Okay. Not too bad. Uh, this has 7 parts. I didn't even read the first part, I just guessed because they all look the same. So I hate those type of questions. It's not really stats. Uh, right? Like if you're doing real world data analysis for your company, they're not going to ask you like multiple choice questions. They just want you to calculate things. So let's calculate. So probability of face or wrist. We don't need to open this in Statcrunch. It's already there. So probability of face is this. Probability of wrist is that. We just add them together. Okay. So for each of them, you just have to add and so on, or do 1 minus. Okay. That one I don't think is too bad. Let's get into, we're not using too much Statcrunch in this section, by the way. This is just sort of a generic multiple choice. So I'll let you guys do that. This one you can just read, right? So there's a little bit of math to do. So it's asking us to find the probability that a randomly selected hospital in Illinois has a score between 5 and 5.9. Okay. Here's that. They're asking about that. So that's 22. 22 out of the total, which is 117. That's the probability. Okay. So yes, it's relative frequency, but it's also probability. Okay, and you do the rest accordingly. 12. This is a bit of a biased question because you have to know a little bit about cards in a deck. So first thing is that you have to know that there's 52 cards. There's 26 red, 26 black. There's 13 spades, 13 diamonds, 13 hearts, 13 clubs. So the probability of a diamond or a spade would be 13 plus 13. Right, you can't have both, so it's okay. They're mutually exclusive divided by the total, and that's that. Compute the probability of randomly selecting a diamond, spade, or heart. That would be 13 plus 13 plus the hearts, which is 13. And let's look at the last one. Compute the probability of randomly selecting a 6 or a club. How many 6s are in a deck? There's 4. How many clubs? There's 13. So we would think it's 13 plus 4 divided by 52, except there's 1 6 that is a club. So let's write this out. So the probability of 6 or club, draw the picture of the club, is equal to the probability of 6 plus probability of club minus the probability of them being the same. So 6 of clubs. Okay. This is probability of 6 is 4 out of 52. Probability of club is 13 out of 52. There's only 1 card in the deck that's a 6 and a club, so that's minus 1 out of 52. What's that? I'll let you guys do this one because I want you guys to try some of these a little more so that you get to try your own ideas out. This one for part 1, you just add them together. So I don't think that one's too bad. So like I said, I'm trying to make these a little quicker. This is where I wanted to get to. So we're gonna focus. Let me just put a random answer. And sometimes I do this. I'm sure you guys do too. You want to restart the problem and get full points. So you just enter anything and then restart. Okay, so similar question. So this is called a contingency table, and it's a very, very important topic. And Statcrunch does it for us. But one of the ones we'll see, I think it's 17. You have to do a little bit, actually it might be 16. You have to change the data a little. So what we're gonna do is open our data in Statcrunch. Then we're gonna hit stat, tables, contingency, and because it already counted the frequencies, we're gonna do with summary. Now this is very important. Make sure your columns are just the data part, right? So we don't want var1, that's the descriptive part. We want the 18 out of 34 and so on. So if I hit shift and I highlight and I get all those in there. I want my row labels to be var1. Then I want to add percent total. Percent of total is going to be like probability. Then I hit compute and I get this beautiful table. You may not like it, but it's beautiful. And here we go. So what's the probability that they are more likely to buy a product when I add? So more likely is this row. And since I already told it to compute the percent, that's going to be my probability. So it's 60.89, which if I round that is 60.9, but that as a decimal is 0.609. Okay. And so you just kind of go each one. So what's the probability that they are 35 to 44 years of age? That's this total right here. The total number of people between 35 and 54 is 496. And the total number of all people is 2025. And Statcrunch automatically calculates that as a probability or percent. So it's 2449. It's this one. So that rounds to 0.245. And then probability that they are 35 to 44 and more likely, that's this row right here. These are the more likely and 35 to 44. You can see the percent there is 14.96%. So it just wants me to convert that to a decimal, and that's 0.15. Okay. So that's that. Question 16. Let me show you guys something here. So I'm just going to enter wrong answers into these. Because the reason I got one of them wrong was I'll show you what happened. So I'm going to show you how not to do this one and then how to get it right. So I'm just entering wrong answers here. You could do this by hand too, but it's a little easier with Statcrunch. All Statcrunch is doing though is it's calculating the total number of things and then finding the percent or relative frequency of each entry, each cell. Let's try this. So watch what happens if you open this in Statcrunch. Do you see how it's already calculated the total here before it didn't? So if you open that in Statcrunch like this and you don't change it, you're gonna get the wrong answer. So if you do stat, tables, contingency with what we have, it's gonna be wrong. We have to delete all the information that's calculated already total, right? We don't want that. We want Statcrunch to do that for us. Otherwise, Statcrunch is gonna think that that's data that we're entering, right? So get rid of that. Then once we delete that row and column of total, we do stat. Why is it not showing? Stat, tables, contingency with summary. Enter the column, so these guys, not the total, get rid of that. And then my row is var1, var1. And then just select percent of total because that's going to be probability. And then that's pretty much it. So the first question is, if an American adult is randomly selected, what is the probability they use social media? This is the total number that, see how the row says use social media. That's why it's important to have the row label. You can see it's 64.55%. So I just have to convert that to a decimal, which is 0.6, 64.5, 64.6, 646. Okay. So all I'm doing is I'm taking the right cell entry, reading the percent, entering that as the probability. Okay. If an adult American is randomly selected, what is the probability they are 45 to 54 years of age? Well, right here, you can see it calculated the total number of adults, 130 that are 45 to 54. And since the total number of people in the survey is 505, what Statcrunch does is does 130 divided by 505, which is 25.74%, as a decimal, 0.257. Okay, and then so on and so forth. Okay, so I hope that helps for that one. Um, let me clear this out. Well, I'll just open this. Show you how to do the same thing. Open the data, It's a contingency table, which is going to really represent probabilities. I hit stat tables, contingency with summary. Make sure you select the right columns. Weather is actually not a column where there's data. It's just a qualitative variable. And my row label is weather. Make sure you select percent of total. That's simple as that. And you can see all these answers came from there. So 0.887 is this one, right? 0.46, that's this one. Okay, 0.416 is this entry, right? So I'm taking the percents, converting them to decimals, okay? So I promised to keep this video short, and I think it was. This one, this is important because we've done these, so let's just remind ourselves how to do these. So like open the data in Statcrunch, and then do stat tables frequency, select the column, and make sure you bin numerical values because it's telling us to right here. It tells us to start at 30 and make a class width of 10, and that's it, right? So Statcrunch does all the work for us. What Statcrunch is doing, if you want to see, is it's sifting through all this data. It's counting every time a number is between 30 to 40, 40 to 50, and then it adds up all the frequencies, and for each row, it finds the relative frequency of each one, okay? So Statcrunch does all that for us. We just enter it in here, okay? Make sure though for the class, you don't put 30 to 40, you put 30 to 39 and 40 to 49 and so on. All right, guys, that's it. I think this was successfully short. I will be uploading a bunch more today and Thursday, so keep an eye out. And as I get further into these, like by chapter 6 or 7, I'll say a little bit about the exam, test 2.